name is Ted Patzek. I'm a professor of petroleum and chemical engineering, and by profession, I'm a chemical engineer and a physicist who works in earth sciences. But a lot of my work was done in environment, sustainability, and ecology. And I will use some of that knowledge today in my talk. So I think that, I think my time is on, so I'll get started so that I leave more time for questions. So as you can see from this first slide, my talk will consist of two parts. One part would be the unimaginable depth of geological time, which can only be visualized by a logarithmic spiral because it's so long. So that's the clock to your left. And of course, superimposed on all of this is us, the ephemeral humans, represented here by my daughter and grandson, who live in San Francisco, and the grandson who gave me the cough that I hopefully will not disrupt my talking too much today. So without much ado, I chose the white background to keep you awakened, so don't squint. Many viewers will be covered with colored images. So I'll give you a summary of conclusions to, I guess, warn you about what's coming. So first I'll show you how ephemeral we are relative to, say, emergence of plants on land. And I'll condense the geological time to 1 year since the beginning of the Silurian period, which is 444 million years ago. I will show you how the continued exponential growth of human population is suicidal and will have to stop one way or another. And I will show you how many humans, roughly, our planet can carry at what we consider to be a decent lifestyle and present life expectancy, but without major strife and with little depletion of natural resources. You will not like the result, but all other choices will lead to a war of extinction, so take your pick. And I will just tell you that our only chance of survival really is by limiting our population and by limiting our consumption. And even mentioning this in the context of academia and affluent society seems to be somewhat unusual, so I'll continue on the subject later on. I'll put humans in perspective using my favorite historian, Ronald Wright, who in his exquisite short book, A Short History of Progress, said this: burning of undergrowth extended grazing lands for game. So humans wanted to have more land to hunt. It is now recognized that many supposedly wild landscapes inhabited down to historic times by hunter-gatherers, so the ancient people who roamed the planet, and in particular the North American prairies and the Australian outback, for instance, were shaped by deliberate fire setting. And man, wrote Lauren Isley, is himself a flame. He has burned through the animal world and appropriated its vast stores of protein for his own. And of course, that burning that started 20,000 years ago has continued and, of course, exploded exponentially as we have created one global civilization and one global fire when compared with so many separate local fires. I'll wait for a second until the new group settles in. But in the meantime, I can show you how it looks like. So NASA, God bless their collective soul, has been watching the planet from satellites, and so do the Europeans, the European Space Agency. And NASA in particular has the Earth Observing System data and a viewer, which is called NASA Worldview. And you can go there and watch how we burn the world in real time. You can set the date and see all the fires, all the thermal disturbances. So if you go kind of from the upper left to the lower right, The upper left is, of course, North America, and most of these fires, which were set by us, the fire apes with big brains and the dopamine stimulus addiction, these fires are mostly caused by climate change, and these are wildfires. As we move south to South America, especially to the Amazon River basin, that huge continental set of fires is the burning of the Amazon. It's nothing new. It's just that our imaging has improved because they're burning the forest and they're burning the underbrush. They're just burning everything. And this is the major fire to convert forest into soybean fields and pastures and oil plantations and what have you. If we move to the east, to Africa, obviously the most fertile part of Africa, the equatorial Africa, the Gabons, the Democratic Republics of Congo, and so on, is an ocean of fire. And that fire has been going on for 15 years at least. I tried to warn OECD about this in 2007 in Paris. And that is palm oil plantations. If you go then to Madagascar, it's both agriculture and plantations, and Madagascar will lose most of its trees pretty soon outside of the steep slopes of the mountains along the island. In Asia, there's lots of wildfires, but if you go to Asia Pacific, just north of Australia, especially in Borneo and Sumatra, these fires, again, are palm oil plantations, and these are major, major fires and major destruction. And Australia has lots of wildfires. And if you look at the reasons for all these fires, this is the net productivity. This is what you can get in terms of net plant biomass on different continents. And the y-axis is irrelevant. It's kilograms of carbon per year. So 1,200 is 1.2 kilograms per square meter per year. And you can see that Asia Pacific is the most fertile. The equatorial Africa, which is not here because most of Africa is a desert or savanna, it's about as fertile as Asia Pacific. Then, of course, it's South America in green. And both North America and Europe are good in summer, but they're not so good in winter and fall. So the reason to burn the tropics is that it's 3 or 4 times easier to grow food there than on other continents. So now I'm going to set humans in geological time. I'll start from showing you the unimaginable depth of geological time on our planet. So this whole circle, this whole pie chart is the story of the Earth. And Earth is as old as 1/3 of the age of the universe, 4.6 billion years. And at the beginning, there was the Hadean period, and the Earth looked like the hot planet to the upper right. Through a big collision, it lost the moon, but the heavy bombardment by comets and meteors ended at about 4 billion years ago. And almost immediately, self-organizing molecules became live, started replicating, and the prokaryotes, the archaea, bacteria, start functioning. And you give them another, let's say, 800 million years, and these prokaryotes started photosynthesizing, and cyanobacteria on the lower right started producing oxygen. And of course, they were very efficient in doing so, and give them another 1.5 billion years, at about 2.3 billion years before present, the atmosphere became oxygen-rich. And that was a complete catastrophe for life, because the original atmosphere was really heavy in CO2 at 27 atmospheres of pressure and methane. And the good cyanobacteria have used up those resources, produced oxygen, and cooled down the planet by reducing the greenhouse effect. And of course, the Earth became a snowball Earth, was frozen. The life, of course, survived. The life never goes away. Once life is started, nothing, I mean, of course, almost all species died and changed, but life never went away even for 5 seconds. So because of volcanism and degassing, Earth was yanked out of this sorry state. And then, at about 2.3 billion years ago, we were beginning to see eukaryotes, which is, the cells which have nucleus, mitochondria, and other organelles, much more complicated unicellular organism. But in a second, I will show you that even when the prokaryotes ruled, there were some pretty complex colonies of them, and there's good evidence how that existed. And then at about 1.5 billion years ago, the blue ring, we started dealing with multicellular life. So, so there were more and more increasingly complex plants or in the ocean. And of course, the simple algae that you see to the lower left helped cyanobacteria in photosynthesis and produce even more oxygen. And so that then resulted in 2 snowball Earths between 750 and 635 million years before present. And again, they were yanked out of that sorry state by volcanism, and which then led to the Cambrian explosion, which is depicted in the upper right. A tremendous amount of new species came to existence in the water, in the ocean. And of course, then about 380 million years ago, we saw first vertebrates, animals with skeletons, land animals, and then later on, that's the yellow bar. And of course, the yellow bar will be, the ring will be our 1 year. This is the time of the land plants since the beginning of the Silurian. And then, of course, later on, we had dinosaurs and mammals. And at the very end, invisible on the scale, we have hominins, we have humanoids and humans, and we are not visible on this time scale. So that's the story of our beautiful planet. And this is the existence of the oldest plant colonies discovered, about 2.1 billion years, and they were discovered in Gabon. What you can see to your left are the fossilized colonies of unicellular plants. There's good evidence they cooperated. There was a synchronized movement of them. And to the right on the black picture, you can see micro-CT reconstructions of these fossils showing their internal structure and lots of interesting conclusions. And to your right, you see an image of a pyritized colony, and the evidence from the sulfur isotopes shows that they were pyritized in fresh oxygen-rich water full of sulfate very early on in diagenetic sequence. So let me talk about now time. So in our new time scale, 1 year will be 444 million years. December will be 37 million years, so we'll go back to Eocene. The last day of December would be 1.2 million years. The last hour and a half of December would be 76,000 years. And the last 20 seconds will be 280 years. So on this time scale, 1 minute is 843 years, so almost a millennium. The peak of last glaciation, 19,000 years ago, happened at 23 minutes before midnight. I'll come back to this because the sea level then was 120 meters below present, and there are some pretty good estimates of what the human population was then, 23 minutes ago. I'll reveal the secrets. We were 2 million people strong. So 23 minutes ago, there was 2 million people. So here's how it looks, this really important year in the Earth's history. And during that year, we made lots of topsoil through the glaciers scraping the rock and crushing it. We made most of coal, crude oil, and natural gas. And so at the beginning, in January, we had the earliest land plants and leafless vascular plants, which were called xylophytes. Then in about April, we went to develop club mosses, horsetails, forest trees, so the primitive conifers, which were called chordates, and ferns. Then they began to really flourish, ferns and conifers, and in May, and by June, they really took over the world, and they became, very similar to the modern conifers that we see them today. And then by August, they dominated the world. By October, we had early flowering plants, so angiosperms, which were not dependent on the wind to procreate. They had their seeds and everything ready in flowers for the insects to help them. In mid-October, the dinosaurs died at the end of the, well, I'll show you. And the mammals spread to all continents in November. Grasslands expanded when the earth cooled in December, and the forest regions diminished. This is when Amazon actually really had some difficulties and became partially a grassland, the Amazon forest, which lasted for, by the way, for 25 million years. And of course, in the last day of December, Australopithecines developed. And so here is the oldest oil seeping out of a dolomitic mud rock, which is 1.6 giga years old. So on that time scale, it's 4 years old. This is in New Zealand. It was found in New Zealand. Here's an artist's rendition of how Earth might have looked like with the xylophytes. And of course, lots of volcanoes, lots of degassing, and lots of changes on the planet. These are the gymnospermae, the naked seeds or the conifers from the Devonian to present. And of course, to your lower right, you can see essentially sequoias and firs, modern plants as we know them today. And they survived pretty well, thank you very much, through all the time. Then the most ancient flowering plants date to about 200 million years, and the oldest preserved dates to the Cretaceous, and many of them survived until today. So let's go to the last month, which is 37 million years. So that's our December, early Eocene, and around the St. Nick's Day, your Santa Day, early primates appeared in North America. Then on day 14, Miocene warming begins, very productive period in terms of oil production, biological production. Then by day 19, grasslands replaced forest over large areas of several continents with the drying up of the planet. Then around the Christmas Day, the Antarctic ice sheet approached its present day size and thickness. Then on day 28, 2 days before midnight, Australopithecines developed in Africa. Then on day 30, a great ice age begins, and the oldest human species, Homo habilis, develop. And then, of course, you can see it even, the human civilization develops right before New Year's Eve. So this is a little bit older than 1 month, so this would be sometime in November, but it's a good picture to show you how the warm planet will look like when it's plus to 8 degrees centigrade relative to the current climate. Of course, there was a lot more deposition by sedimentation between then and now, so not everything that is submerged here will be submerged then, but you can see that most of South America is submerged, so the southeastern North America, the Arabian Peninsula, of course, has not really separated from Africa yet, and the Red Sea didn't develop. India didn't quite join Asia. Asia is much, much smaller. Europe is a set of islands with Scandinavia completely, far away and apart, and Australia was also partially submerged. So that partial submerging will occur as the global warming happens, within the next century or so, and there's going to be some very substantial changes to the coastal areas. And so if you look at some of the small animals, the critters, they look quite familiar to us. They don't look much different than from what they are today. And then, of course, Homo habilis appeared during the early Calabrian stages of Pleistocene about 2 million years ago. So that's one of our predecessors. And so let's go to the last day of December, which is 1.2 million years. So this is the last day before New Year's Eve. So at about 10 o'clock in the morning, the common genetic ancestor of humans and Neanderthal appeared. Those of you who do human genetics could question me, and I question myself. These are somewhat questionable markers, and the modern genomics says that that's not quite true, but it doesn't matter. It gives you a nice orientation. And by about 5 o'clock in the afternoon, Homo heidelbergensis left the footprints in the powdery volcanic ash. And by 9 o'clock in the evening, at Omo River in Ethiopia, we had signs of the earliest Homo sapiens, the thinking human, right? At 10 o'clock, female ancestor common to all lineages in human alive today appeared. Again, that's a shaky evidence. By 11 o'clock, the anatomically modern Homo sapiens appears in Africa. And just before midnight, human civilization develops and glaciers retreat. So here is the history of the human species. Of course, it's much more complicated. There were many side branches, and we're still working on it, how it actually looked like. But it's about 3 days on this time scale. So this is how old we are from the Australopithecus to the Homo sapiens sapiens, which is a kind of a strange name. The thinking human, that is an overstatement for us. And here is the Neanderthal, a subspecies of humans, about half a day old, very heavily built, with much larger skull, larger brain, but unable to speak and unable to pass knowledge to next generation the way that the Cro-Magnon people who moved from Africa when the glaciers retreated and killed off, exterminated Neanderthals, and also interbred with them. So some of us have still Neanderthal features today. This picture of glaciation is about a little bit older, so it's 2 days before present, but it's not much different from the recent glaciation, which was 23 minutes ago. And you can see the heavy ice sheets covering the parts of Asia from this northern projection, Greenland, most of Canada and North America, and of course there's lots of temporary ice all over the planet, and of course in the Himalayas. So this was the dry earth, very similar to where the hunter-gatherers lived 23 minutes ago. And based on the analysis of some 245 tribes of hunter-gatherers, their population, the most likely median population was about 2 million people. The high estimate would be reaching 8 million people, but the density was between 1 person per 8 square kilometers to 1 person per 22 square kilometers. Okay, so it has not changed. If you do the calculation today, if we were to have enough habitat to support hunters-gatherers, the population today, given the habitable land today, would be the same 8 million people. Okay, so this is 8 million supported by the planet in hunting-gathering. We can discuss the fine details of it because when it comes to rich fisheries, the population density would be very much higher. So let's go to the last hour and a half of our wonderful year. So about 73 minutes ago, most recent ancestor from whom all male Y chromosome CAM appeared. Again, that's questionable, but it shows how much more fragile men are than women. Modern humans expanded from Asia to Australia and Europe an hour ago. Then about 37 minutes ago, modern humans entered North America from Siberia through Alaska, and that completed colonization of the planet by the humans. Okay? The whole planet was now colonized. And of course, that's North America. It took them a few more minutes, up to minute 11, to reach to South America. In the meantime, on minute 33 or so, Neanderthals die out. It's not die out, were exterminated by people who had superior weapons and superior war technology, which were the Cro-Magnon people. And then about 12 minutes, I already said that. So about 9 minutes before midnight, earliest evidence of human civilization and culture appeared in Mesopotamia. Some of the cities are twice as long, so that would be 18 minutes. And then on minute 7 or 6, Egyptian civilization appeared, and then on minute 4, the Greek civilization also appeared. So let me spend a little bit of time talking about Mesopotamia, the Fertile Crescent, as it existed, some 5 to 10,000 years ago. The first big cities on this planet, the first cuneiform writings that were shown to you yesterday, showing the positions of planets, were actually acquired in Babylon, Uruk, Eridu, and Girsu, and so on. And by that time, by about 10,000 years ago, Earth climate actually calmed down enough to allow enough continuity for people to breed plants from one year to another. And lo and behold, in that absolutely fertile crescent, people have bred plants, and modern wheat, rye, oats appeared in what today is Iran. As people continued their agriculture, they had to water the soil and salinate it and destroyed it. And so the whole population moved north to Assyria and then all the way north and west to Anatolia and to Turkey. And if you look at what 10,000 years of human agriculture does to the earth, you can look at Iraq today and the complete environmental devastation that was brought upon humans in the last 10,000 years. So there is your oldest pyramids, 2,600 years ago. I'll stop a little bit to talk about the incredible impact of the Greek civilization on the modern civilization. And I like Whitehead's comment. He said, the safest general characterization of the European philosophical tradition is that it consists of a series of footnotes to Plato. But I have to say that without the enlightened Arab civilization of the 7th, 8th, and 6th to 8th centuries, and the subsequent translation of the Greek texts, which were translated to Arabic and back to Latin by the Jews who lived here in the Middle East, we wouldn't have that evidence of the Greek civilization. It would have disappeared. So let's look at the last 20 seconds before we pop that champagne bottle, right? So in second 18, we had Watt's steam engine, the beginning of the Industrial Revolution. In second 17, we had Declaration of Independence in the US, a very important event for the modern democratic systems, which is being trampled upon today in the same United States. On second 14, world population reached 1 billion. On second almost 12, US prairies were plowed. one of the most fertile regions on the planet, and most of the forest that extended from New York to Chicago was logged and destroyed. In second 12, oil was discovered in Pennsylvania, giving rise to the modern oil age. On second 10, mass oil and automobile production starts in the US. Second 7 is very important. That's the Haber-Bosch process becomes commercial in 1920. Of course, Haber-Bosch produced ammonia, and it was not used for fertilizer. It was mostly used to produce better explosives for the war effort. But after 1945, all these munitions plants were demobilized, and a huge nitrogen fertilizer production started. So that's really the last explosion of human population. That's mostly due to the Haber-Bosch. And antibiotics and better hygiene. But, so in second 7, world population became 2 billion. So it took us about 7 seconds to double on this time scale. In second 6, Americans dropped atomic bomb on Hiroshima. I'll comment on this in a second. On second, let's say 3.5, we can discuss that whether it was 1/2 or 1/3, I don't care. A lot of oil was produced in the US. On second 3, before midnight, half of the cropland topsoil was eroded in the US, transferred to the Mississippi and Missouri rivers and down to the Gulf of Mexico. It's very significant because it took us only 9 seconds to destroy half of our endowment. And on second 2, world population became 6 billion. So here's the James Watt improvements of the Newcomen steam engine, and that's the beginning of the modern industrial era of 1800s. This is the Declaration of Independence in the United States, a very noble act that actually ushered the modern era and modern democracy. Carl Benz of the Mercedes-Benz venture produced his first cars by 1885. We dropped 2 atomic bombs on Hiroshima and Nagasaki on August 6 and 9, 1945, and killed almost 130,000 people. That's very significant because it stopped nuclear war for the next 70 years. But today, many of the younger US commanders think that a tactical nuclear weapon with weapons similar to those two is winnable, and that spells an incredible danger for the world. So here is the last 2,200 years of the human civilization, a couple of, a few 120 seconds or so, but that big blip in fossil fuel consumption, which is going up to 600 exajoules now per year, that's occurring right now. And again, people will squabble, and I will agree that we have to move the back end of it a little bit this way or that, bulge it with some more oil production, fine, doesn't matter. This is what it is, okay? And also please note that once we go from 600 to 400 exajoules, which is very soon, or very, very soon, or just very soon, that's a 30% reduction of GDP, because oil is GDP. Then the global economy goes away forever. The global finance freezes, and we're going to have to reorganize the world completely. Okay, so that's coming soon. So the duration of our industrial civilization is 30 or perhaps 35 seconds on this time scale. And I want you to ponder this for a second, or 2 seconds in real time, because we all think that what we have will last forever. No, it won't. Okay? So I want to remind you that we only had one shot at the global civilization, and it shall never be repeated again. Okay, so we are it. And it applies to planet Earth or any other planet in which a global civilization developed. So all this talk about, sending human colonies to Mars, and that's, this could be more or less nonsense, because if there's not enough resources to send them, they won't be sent. Okay, and those major projects can only be supported by a global civilization, as is the Hadron Collider and everything else that surrounds us. And KAUST. So let me talk about exponential growth. So there's too many of us, and we are very resilient reproducers, and we are accelerating overshoot by attacking the self-reproducing resources and by attacking waste assimilation capacity of the ecosystems. The growth of the human population economy is being subsidized through the liquidation of essential biological assets of the planet, which is ozone layer, drinking water, soil, fish stocks, biodiversity, and the overfilling of the sinks, which is any global carbon sink, atmosphere, oceans, deep aquifers, and so on. And this environment, and let me stop here and tell you, this subsidy occurs mostly because of modern economics, modern financial system. We have electronic money, electrons, which is sloshing around the world and going after every juicy resource there is. So we are destroying the earth everywhere now, and it's now China, US, everybody else, right? Because there's too many electrons, and we believe that these electrons matter. That's actually something really nice. So these environmental subsidies of the overshoot can last only as long as the critical asset in the least supply. And it seems that the atmosphere and oceans might be those two assets, and the global warming will accelerate while the fisheries go away. And I want to kind of impress upon you that none of this is captured by the economic models of the world and the common thinking of the developed societies. So let me give you an example of exponential growth. That's a well-known example, but most people have incredible difficulty imagining what it means to be under exponential growth. So I want to so we had one lily one day, and she was the lonely lily on the pond, and she divided and doubled every day. So on day one, there was one lily. On day two, there was two, then four, then 4 squared, which is 16. And on day 19, there were 524,000 lilies or so. And on day 20, there was over 1 million lilies. Okay. So the question, on what day was the pond only half covered? And you know the answer. It was on day 19. On that day, 95% of the lily history was already over. But from the lily pad species perspective, the pond was still half empty, and there was plenty of room to grow. Do you recognize this narrative? When you hear about growth, always grow, right? We cannot not grow, we grow. Okay? So this is how most people and economists perceive availability of resources. So here are our lilies. They grew up from 1 to 1 million in 20 days, and then they died because they exhausted all resources in the pond. And here's the same lily picture for humans. It is not as simple. So these are the doublings of the human population from, let's say, the initial cohort of people of 10,000 people about 250,000 years ago. The timescale is logarithmic because it's such a long time, and I wanted to capture the recent times and go a little bit into the future. So you can see that initially the population was low. The doublings were not occurring so fast, but they kept on accelerating, and then we reached 5 doublings, in about 1800s. And then the rest doublings occurred later, and in 1990 we were at 19 doublings at 5.2 billion people, and then of course the last doubling, which is on this plot, will be in 2070. There will be what, about, you tell me, well, 10.4 billion people, right? And my suggestion is that the 21st doubling will never happen, cannot happen. We have overshot so badly, okay? So something will have to happen between now and then. And so this is how it looks in terms of adding population. So it's 1 billion, 2 billions, up to 8 billions. So it took us 123 years to go from 1 billion to 2 billions. Then when I was born, we were going to 3 billions. It took us 33 years, then 14 years to go to 4, and now it's 13, 12, 12, 12. So it takes us about 17 years today to add one population of China in 2014. And that's, of course, absolutely, totally unsustainable. So let's look at the local population in Saudi Arabia. So the Arabian Peninsula with fishing, with fisheries mostly, and agriculture could probably support 3 million people. And the population of Saudi Arabia was of that order in 1950. And if you look at the UN predictions and the census data in Saudi Arabia, we are currently at about 30 million people. And if everything goes according to schedule, we will peak at around 50 million people. And if you look at how long does it take to add one population of Riyadh in 2015, or 4 million people in Saudi Arabia, so initially it took 24 years, then 9, 6, 7, 7, 6, 6, 7. It's going to start slowing down to 10, 11, 17 if everything goes according to schedule. But you can see that we have exceeded here the historical level of population, let's say 3 to 50, by a factor of 16. 16. It's an order of magnitude. Okay? If we look at the population of Egypt, the Nile Delta was able to support between 1 and 4 million people. I think I plotted 3 here. When hunger came, people died of hunger. There was lots of children, very high child mortality, but it was pretty steady. And by the way, it was that way up to 1870 when the Brits started growing cotton and gave guano to the Egyptians, and they started multiplying because food supply also increased. So today we are at about 102 million people in Egypt, and by the way, 2100 we would be over 200 million people. That's impossible. That's an ecological catastrophe, and Egypt will have to implode soon, no matter how much cash is being poured into it, and millions of people will pour into Europe and into Middle East and wherever, Africa. So let's look at the population of China from many sources. That plot actually warrants a separate lecture because there's lots of really wonderful sustainable agriculture in it. But you can see that, over the last 2,000 years, most of the time the population of China was between 50 and 100 million people. There was hunger in at least one province in China at any given time, but the agriculture was able to sustain that population. And then by the 1750s, there was more modern agriculture, guano came in, and of course, then the population started exploding to 600 million people when Mao came in 1950 and the agricultural revolution came in, boom, boom, the thing happened to 1,400 million people. So 50 over 1,400 would be half, would be a factor of 28. Of course, right now, China has been the only country with one-child policy which successfully limited growth of its population, because people in China no longer want to have 5 children, even when they can, because they figured out it's not good for them and for their children. So that's the population of India over the last 2,000 years. And again, historically, the population of India has been around 50 million people. And then, in the more modern, the red times when the Brits started messing up with India, there was some hunger, some strife. But, by the time the Green Revolution came, the India population shot to about 1.2 billion people. And so again, half 1.2, a factor of 28. Okay, right? So remember these factors. And so I thought about this for a very long time, and I was trying to see, well, what would be my estimate of a sustainable human population? So that's the last 3,000 or 3,100 years of human population. And this first bar is the beginning of the Industrial Revolution, okay? And the second one would be the modern era of modern industrial world. So if I were to extrapolate the population growth and then turn it down and saturate, then today we might have 2.5 billion people living on the planet, not 8. But that's a debatable result for the following reasons. So suppose that we had 2.5 billion people, but this would require the 1800s life expectancy, lifestyle, slavery, and conflicts. Okay? Average life expectancy in the 1800s worldwide was 32 years. Average life expectancy in 2015 was 71 years. So if you ratio the life expectancies, that brings down this number to 1 billion people at today's life expectancy. And again, in 1800s, the world GDP per capita was $600, purchasing power parity, so equalized dollars, and it was 8,000 roughly in 2010. But again, I have to discount the silly economics. You know, the economists will tell you that the world is brought out of poverty because the income has increased so much. But that's an idiotic statement to make, and don't believe it. Because let's say if you are in a village in Ghana, you walked behind your hut, you picked up fruit from your orchard and vegetables from your plot, and you lived very happily without any cash. So you were dirt poor, but you had clean water and you had good food. Today, in the same village, you have a store which sells Coca-Cola and potato chips. And to buy them, the local population has to get income from people working as taxi cab drivers in New York or wherever. And on the surface of it, they are much richer, but they're not. They're actually much poorer. So let's suppose that this factor of 11 or 12, whatever, really, if you account for the environmental services, is only a factor of 2. Well, that brings us down to 500 million people at an average world lifestyle. Okay? That's very far from the Western European or American lifestyles. But we don't have to have wars and strife, so I guess the final, and we can squabble about this, maybe it's 300 million, I don't care. So a factor of 2, so it's 250 million people. So in that simple estimate, the Earth can carry less people, fewer people, than the current population of the United States. Okay, so that's what it is. And according to this calculation, we have overshot by a factor of 30 using fossil fuel subsidies. And I'm going to just finish by showing you that human population drives everything else, drives the destruction of the planet. So here is the power production of all sources of power. In blue, normalized between 0 in 1820 and 1 in whatever year I finished this, 2015. And then the same goes for the population, 0 and 1. You can see that 1 corresponds to the other, except that in the 1950s, power increased faster than the population because of the consumption binge in the United States following the Second World War. So these are the good Eisenhower years in the US. If you plot the normalized power consumption versus normalized growth, the relation is 1-to-1. Let me give you now an example which is less abstract, what it means to destroy natural resources. So this is Key West, and Professor Volker Fahrenkamp is right there somewhere, yes, and he's been fishing there and scuba diving there, so he can tell you firsthand what a beautiful, pristine habitat it was even 30 years ago, but that was 60 years ago. So the competition went like this. You had to leave the port at 9:30, you had to come back at 4:30, and you have to present what you caught in a single boat. So this couple with their little daughter caught more fish than they knew what to do with, and huge, giant fish, that's all they did. That was 60 years ago. 30 years ago, it's the same one, 9:30 a.m. to 4:30 p.m., 11 people now on this, so a much bigger boat. Caught substantial number of fish, but these were much smaller fish, okay? And then a decade ago, this was the catch in the same competition. That's what's going on worldwide when we really see what's happening with the fisheries, and that's what will happen to the Red Sea as well if we continue what we're doing. And now this is the Chinese trawlers head out to sea, thousands of them, because they were kept in port for 3 months because of the overfishing. But that's kind of hopeless. And so here's the same plot for fish consumption and human population normalized between 1950 and 2015. So the red one is the accumulated global population, and the blue line is the cumulative fish consumption. You can see that first we didn't like fish, now we like fish more, but one is very close to another, and you can do the same trick, plot cumulative fish versus cumulative population, and you can see that the fish consumption caught up or even exceeded now the trend, the human population, just in time for the oil fisheries be depleted in about 10, 20 years from now. So I'll finish because there will be a lot of talk about, how can we develop sustainable resources, and I think I can make some comments on this subject. But this is oil production rate in millions barrels of oil for 4 countries I chose. The red one is Venezuela. The oil production has peaked and declining. The blue one is Mexico, and of course with the Cantarell collapsing, the production is collapsing. And as you know, both countries are in severe, severe problems for one reason or another, not just oil production, but other problems. If you look at Colombia, Colombia's production has stabilized, and they signed the FARC deal just at the last moment to keep the country afloat without falling apart. And in Brazil is doing fine, but because of the corruption and so many other things, Brazil is under now a right-wing government, which will not do well for it. Anyway, so with this, I will thank you, and I will encourage some discussion now that you are appropriately, I know you are such a pessimist, you will tell me, and I'm not, okay? And so don't be depressed, just face up to reality and move on with it. I have a grandchild, and I have 3 children. I won't have 9 grandchildren. I may have 2 or 3, maybe only 1, and that's just right. But I'm very concerned about the fate of my grandson. Okay. All right, so here we are. Let's have some discussion.
Thank you very much for such a nice talk. So it has been said that the 11th billion person will never born, which is an estimation that is considering the current birth rate and fertility rate. The global population will stabilize at 11 billion. That's right. So according to some estimations. What are your thoughts about that?
Well, so again, I agree with you. If you look at my simple doublings, right, wherever they are. No, that's wherever they were. Here, right? So we went to 5.2 billion, and then 10 billion people in 2070, and something has to happen because we cannot continue on that straight line up. Okay. So whether it will saturate at 12 billion or fewer, we don't know, but it has to saturate at some level. So in general, you are right. I already said that's impossible. That straight line up is physically impossible. Okay, so whichever choices we will make, but if there's a global one-child policy everywhere, then we'll make those choices faster. Okay. Yes, somebody there.
Professor Patzek, thank you for your talk. I would like to ask you, how can we contribute for this change, and what do you think is important to have stronger regulations for the birth control? Thank you.
Lovely question, right? Not a very popular subject in most countries, is it? Including the United States. We have to face up to reality. And United Nations has to be empowered to distribute contraceptives. They have to be easily available everywhere, but there also will have to be some social policy change in which reduction of the number of children will be strongly encouraged as opposed to discouraged. The governments are blind because remember that our entire civilization is a Ponzi scheme, right? It's a falsehood built on the fact that more young people will produce income for the aging population, for people like me, so they can safely retire and live happily ever after. And so the population growth is absolutely required to maintain the current economic model. If you limit the population growth, you destroy the current financial model of the world and the economic model of most countries, which means that nobody's gonna agree to this easily. In fact, most people will say, you are a dangerous subversive if you say that we will have to limit growth, okay? So in fact, you can see signs of the cracks appearing everywhere. You just saw Brexit yesterday, and Great Britain, which is a basket case in many ways because it's an oldest industrial country. It's the country which exhausted its coal some 20 years ago. And it's a country which is absolutely vastly by a factor of 40 overpopulated and depending on everything from the outside world. And you see what's happening there. You see what's happening in the United States, in other European countries, in other countries around the world. So the current system will change, but not in a nice way unless we work. We all work on it. You are very, aware that unless those of us who can still vote, don't sit at home, don't watch TV. We don't watch TV, we do other things, and we live in different ways, right? Consume less. So that's all I can say. And how you're gonna make your choices, it's up to you. I cannot tell you, and I won't tell you, but you have to be aware that you have to make choices for you and your family, because otherwise it's gonna be bad news. Yes?
So I have read an article some time ago, and the author of the article was saying that we should not care so much about the growth of the population. We should think about the reason of why people choose to have a lot of children. And he compared the population growth in developed country against less developed country. And he said there is a biological factor. So in less developed country, the likelihood of a child surviving to adulthood is less, therefore they have more children. So we should, his argument, focus more on increasing the healthcare and education, because once we do that, the population growth would decrease automatically.
You are absolutely correct. So the first thing is empowerment of women. Once you empower women to be in control of their own bodies and fate, then they have many fewer children. That's a given. So all the developed countries have many, many fewer children. The fact that sub-Saharan Africa, let's say, has a very high death rate, that's inevitably true. And there's a social strife. There's, you look at the Sudan and Somalia and all these countries, and they're horrific, okay? And I don't know how you handle this, but, their populations are exploding. So it is not true that, that the high mortality exceeds their expansion of their societies. People overreact. So the only way to bring down the population is to bring in social stability, healthcare, and education. Okay, and again, that's above my pay grade. Yes, there was a question right here. I don't know where the magic ball is. Okay, yeah, but it's transmitted, so nobody will hear you. Can I have the? Okay, so you first ask your question first. Yes, sorry.
Hello, Professor. It's a very nice talk, but I would like to ask one question. maybe you have thought about it a long time ago. Currently, we all know that the exponential economic growth is not sustainable. However, the current economic mainstream genre, they believe technology. They say that, okay, we have run out of conventional oil, and then we develop a shore oil. Maybe after 10 decades, even more better technology will develop, so even more unconventional will be extracted. So, such as a peak oil theory or any King Hubbard believer, they are all wrong.
Of course, they are.
Do you have any comment?
Yes, that would require a separate lecture because there is no single comment that will suffice to answer your question. Remember that people have been developing technology for the last 2 million years. And for the last 2 million years, each new technology was supposed to solve humanity's problem. And yet, over the last 2 million years, each new technology created its own new problems, which were then solved with yet again new technologies. So the belief that technology will be the savior is complete delusion, but it's a very human delusion. So people who think that are deeply delusional, but I can't help them, okay? So because each new technology creates many more problems, which actually then have to be solved with yet another technology until we run out of technology. So that's one answer. The second answer is that we are getting dangerously close to, as you just said, to the deep offshore oil and shale oil. Well, these are either very inaccessible reservoirs or really terribly bad reservoirs. I mean, there's big resource, but really bad reservoirs. Only places in this resource can become reservoirs, can be produced. And I'm a petroleum engineer. I could give you a 2-hour lecture on this subject. So yes, there will be more production than I indicated on that red curve because I didn't have time to do all that development on paper. I can do it. Doesn't change the big picture. It just buys us a second or two, okay? Makes no difference, okay? And it causes other things to happen. Oil equals consumption. Oil is the enabler of the global economy. Without oil, there will not be a global economy. There could never be a global economy, okay? So as the flow of oil slows down, and it will slow down, because increases here will be more than outmatched by decreases there, the economy will have to slow down and then possibly fall apart if we continue on this path. But that's really, if you want me to talk about this in a more informed way, that would be a 2-hour lecture. Okay, so sorry. All right.
Okay, I have a question regarding the alternatives of controlling the world resources, right? You said that only one option regarding the population control. Do we have other alternatives?
Like what?
For example, to distribute the wealth equally?
Okay, all right. So this is actually a very interesting question. So you see, okay, you see that calculation? So the way I distributed wealth here is that I said that the wealth will be distributed to everybody to double their current, the 1800 lifestyle in terms of both environmental services and wealth. That is a factor of probably 6 away from the standard of living in the US or in Western Europe. So your question is actually, that's an excellent question, but how do we distribute those resources? To what level? Because if we distribute it to the average level of consumption in India, okay, which would be a great thing to do, okay, then obviously we can carry more people. If we were to distribute it to the level of Germany or the United States, that number, 250 million people, would become, I hate to tell you, 90 million people, okay? That's the supported population of the planet at the current lifestyle of the United States. So I agree with you, wealth needs to be distributed. That is the reason for all this upheaval in politics worldwide. But how do we do this? There's no model, no concept, no guidance And in fact, we in America deeply oppose this on ideological reasons, because our capitalism means this: what I have is mine, and if you don't have it, well, screw you. Okay, that's basically, that's what we say to the world. Okay, yes.
Hello. Thank you for your lecture. Can you show a slide with a graph when you show the energy consumption per year and the prediction of it? But you said that in the future it will go down because of oil depletion, yes?
Well, oil depletion, environmental constraint on coal production. There's plenty of coal. It's more difficult coal, but there will be. You see, I haven't talked about climate change. Okay, you're forgetting about this because we are technological people. So we only think about oil, but we don't think in what context that oil production is occurring. That's the context of increasing CO2 emissions and environmental destruction by the global economy. So you tell me what you want to do.
Yeah, I want to shift to methane.
Yes.
Yes, methane is great, I think. Like when the oil will be depleted, we're going to shift to methane that maybe will be depleted in 200 years, but it's still produces less CO2. I mean, it's my belief that there will be some more resources that will lead us, like before thermonuclear reactors, that will produce energy like for everyone with zero greenhouse gases. So because it's more about belief that maybe I think that technology will help us just for a minute until some better technology will come. When you say that when the oil will be depleted, we will use coal, okay, methane, oil, okay, but it will produce more problems, as you said.
Yes. So thank you for this comment, because it wasn't really a question. This was your rejection of my arguments because you are a citizen of the global amoeba. Okay, so you actually represent a very typical thinking of most people on this planet. Okay, so you are saying, well, don't worry, nothing will happen. I disregarded the climate change, the population growth, the depletion of resources. I'm going to have nuclear reactors and they'll solve our problems. No, they won't. Okay, that's the short answer. Yes?
I have also a comment more than a question. And also includes climate change and technology as the question of the guy behind me. So now we are also trying to improve of health. There is even an institution, Human Longevity Corporation, that is aiming for us to live longer. And new technologies are not taken into account, or maybe the exponential growth and the plateau that we are supposed to reach in 2100, I think, as I remember all my classes, are not considering the new technologies. For instance, there is this paper in Nature Climate Change that says, if we implemented the cryptocurrency, there will be an increase of more than 2 degrees by 2033. So this will also affect all these estimations that we have. It's not only just oil or other things.
Right. So again, is Natalia here? Yes, she's there. So she just showed me her calculations of the average temperature changes. Was it in July? The average temperature in Jeddah, in Riyadh. So those average temperatures have increased by 2 degrees centigrade already in the last 30 years. So the Middle East is heating much faster than the rest of the planet. Okay? So we're going to have to wake up from this stupor and not say that another new technology will come by. And one of the problems with the medical technologies, which some people say will allow us to live 200 years, well, look at that calculation. If you do 200 years as opposed to 71 years, and you want us to all live a decent lifestyle, you're going to divide this population by a factor of 3 again. So there is your calculation right here. So medical people think how to increase our lifespan. Other people think how to kill us better with new AI-driven autonomous robots. And somewhere in between, the truth will emerge. Okay? And remember that we are setting ourselves up for a big correction. And historically, the world has been at peace only a few % of time in the last 2,000 years. So what is the most likely correction? You tell me. Well, tell me. What's the most likely correction? War. Yes. War is always the correction of choice for humans. Okay? But you see, because of the progress and new technology, our weapons are now so good. So, you know, a bow and arrow was a much better weapon than a club. Whether there was a spear in between, the Greeks used it very well, right? And so then the bow and arrow was much better, and the Mongols used it in light horses and created the largest empire in the planet by the 1200s, okay? And then the powder-driven weapons, the muskets and the rifles, were much better weapons again. And so we had the First World War and the Second World War and many wars in between, right? And we conquered the whole world using those. Europeans did because we had much better technology than anybody else, okay? And then we had even better weapons, that would be airplanes and bombs, and that was World War II, okay? And now we have better weapons yet again. They're called nuclear weapons and missiles, right? So now our weapons are so good that if you ever use them once, we're going to evaporate, okay? So there's your technology for you. What? Yeah. Well, I'm just telling you how the progress of technology. And remember, we're working day and night now on artificial intelligence and deep learning so that the robots we unleash in the battlefield will recognize the enemy immediately and kill them at a very low price and very efficiently. So that's upcoming attractions. All right, I think we need to finish because half of the audience left. But if you have any other burning questions, I'll be happy to answer them later. Again, I apologize for condensing so many stories into 1 hour because I cannot do justice to so many other elements of the story, such as the climate change, such as the exhaustion of the oceans, such as what happens when you try to introduce renewable technologies and you run out of the wrapper of oil and gas. And you won't be able to do that, by the way. So there is so many other elements to that story, and I still do thank you, and let's finish. All right? Thanks.